Okay, this is going to be our first video on variables and expressions, and I am just learning all of the software and tools here, so you're going to have to bear with me a little bit today. So first of all, if we were in class, I would have given you a warm-up, so go ahead and pause the slide if you would, or pause the video, and I'd like you to do these computations without a calculator. Very simple computations, just want to make sure we've got our math skills back up to speed. So go ahead, pause the video, answer all these questions without a calculator, and then restart, and I will give you all the answers. Okay, check yourself, make sure that all went okay, and moving on. All right, so our objective today is to translate between words and algebra. By that I mean letters and numbers and words that describe it. And we'll see in a minute what that means. And then we're also going to evaluate algebraic expressions. Here's some vocabulary that I would like you to be writing down in your notebook. First, it's a variable. What is a variable? A variable is any letter or symbol that we use to represent a value, and that value can change. So what would be an example? A variable might be an X or a Y or an N, or basically any letter you would choose. So a variable is a letter or symbol used to represent a value that can change. A constant. Constant is just going to be a number. It's a value that does not change. So any number you can think of, 23, 2014, negative 33, those are all constants. A numerical expression contains only constants and operations. Okay? By that I mean it could be something like 3 plus 16. Or 74 minus 12, or 92 times 1. Anything that contains only constants and operations. And finally, we have an algebraic expression. Obviously, we're including the algebra, so we're going to have variables, constants, and operations. So anything like 3x plus 2, or 4y minus 7, or 16x divided by 3. Any of those would be algebraic expressions. Okay, so I told you we were going to talk about changing things between words and symbols, and so here are a few examples. And write down these examples, please, and write down the words that fill it in. So in this first one, you see there's a 7 and a plus sign and a Q. Well, one way of saying that might be 7 more than Q. In fact, with addition, it really doesn't matter which way you said that. So I could say 7 more than Q, or I could say Q plus another 7. So something like, here we go, 7 more than Q. And how about here? We've got 3 less than N. 3 less than N. Whoops, having a hard time with my pen, but that's okay. Less than N. This next one, we've got division going here, so we really have R divided by S. And finally, we have 3 times the quantity H. Okay? So we change between words and symbols. So let's look at some examples of that. So Lou drives at 65 miles per hour. We want to write an expression. An expression, remember, can contain constants and variables, but it's never going to have an equal sign. We'll get to that later, but for right now, we're just looking at expressions. We're just going to have some kind of operation sign with a constant and or a variable. So Lou drives at 65 miles per hour. Write an expression for the number of miles Lou drives in hours. Well, what does Lou drive? He drives 65 miles per hour. So every time he drives an hour, if he drive, let's replace hour with a 1. Well, he would drive 65 times 1. Or he drives 65 times 2. Or maybe he drives 7 hours, but every time it's 65 miles an hour. So that 7 or that 2 or that 1 is the h. So an expression that represents any number of hours, any changing number, would be 65h. Cheryl is 5 inches taller than her sister, Carol, who is 5 feet 2 inches tall. Write an expression that represents Cheryl's height. Well, we've got Cheryl over here, and then we've got Carol over here. And what's the difference between their two heights? Well, we know that Cheryl is 5 inches taller. So we could take away 5 inches from Cheryl's height, and that's going to be Carol's height. Or we could take Cheryl's height, and we know that she's taller than her sister. So if you added 5 inches to Carol's height, that would be the same as Cheryl's height. So either one of those situations will work. Okay, so to evaluate an expression means that we're finding a value for that expression. So I've got an expression, but I need to know, I want to be able to plug some number in to find its value. I'm going to give you those values. So if we know what that variable equals, we can find the value of the expression. So here's our example. It says, evaluate an expression given that, here is our scenario, x is equal to 3, y is equal to 8, and z is equal to 2. Well, every time I have an x, I know that's really equal to 3. And every time I have a y, I know that's really equal to 8. And my operation was to add, so 3 plus 8, of course, equals 11. Here, those variables are next to each other, which implies multiplication. So I've got that 3, remember, and my y of an 8. So I've got 3 times 8, or 24. So in fact, I know the value. I can evaluate that expression. Here I've got y divided by z. Y is 8 and z is the number 2. So that expression, the value for that expression given those values for x, y, and z is 4. Okay? All right, so just to make it clear, when you have both addition and multiplication, so let's say I have this equation, or this expression, I apologize, this expression x plus y plus x is the exact same value as x plus y. I can write it either way, okay? Also, with multiplication, I can do the same. So xy is the same as yx. Those have the same values. Okay? Now, in division, is it going to matter if I put the y or the z on top? Well, is there a difference in value between 8 divided by 2 and 2 divided by 8? Yes, there sure is. So division, that's not going to hold. You have to put it in the specific order. Likewise, with subtraction, you're going to need to put the variable in the correct order. If I say that it is 3 less than n, 3, let me write that over here, 3 less than n, then that needs to be n minus 3. Okay, I can't do 3 minus n because that's n less than 3. So that does not work. Okay, so that should be it. And we're going to just work on some practice in class tomorrow. So thank you for watching your very first video. Appreciate your time. And I will see you tomorrow in class.